Welcome to this explainer. Today, we are literally opening up the examiner's playbook to demystify exactly how packet switching passes messages across networks for your Cambridge computer science exams. Think of this session as the place where ancient warrior wisdom meets modern exam strategy. We are going to teach you how to become the last samurai of the exam hall, learning to slice through the most complex, intimidating network routing questions with absolute, unwavering precision. So let's dive right into this and set the scene. I want you to picture a dynamic split screen in your mind right now. On one side, we have a student named Alex. Now, Alex works hard. Alex has memorized every single textbook definition of a router, an IP address, a payload, you name it. But system to completely ace these questions.
Because get this, did you know that mastering this single topic of packet switching accounts for approximately 15% of your total marks in paper 2? Seriously, 15%. That is a massive chunk of your overall grade just waiting to be claimed. And interestingly enough, this 15% isn't just about reciting what a packet actually is. Cambridge examiners use this specific topic to rigorously test your algorithmic thinking. It doesn't matter whether you are studying for syllabus code 9618 or if you're building your foundational skills in other Cambridge computing courses like 0417, 0478, 0983, 0984, or 2210. The examiner's objective is exactly the same across the board. They want to see if you can break down the complex journey of data across the internet into logical, calculated steps. Remember Sam and Alex? They lost their marks because they simply didn't respect the weight of this topic. They treated a highly technical, multi-layered 8-mark question like it was just a simple 2-mark definition prompt. We are going to change that mindset right now. To secure that 15%, we absolutely need a battle plan. Today, we're going to systematically break down exactly what examiners are looking for by covering 4 key areas. First, the core principles. Second, the procedural framework. Third, critical analysis. And finally, the top examiner warnings you need to look out for. Let's move straight into our first major section.
Section 1. Core Principles. This is really the foundation of top-tier, high-scoring answers.
So top students really distinguish themselves across 3 distinct cognitive domains that the assessment objectives target: knowledge and understanding, application, and analysis. It's not enough to just know the facts. You have to apply and analyze them. To slice through a packet switching question with the disciplined technique of a samurai, you must deploy the PEAL framework. You've probably heard of it. PEAL stands for point, evidence, explanation, link. Let's say you're asked to analyze network congestion. Your point is that packets take varying routes. Your evidence is the role of routing algorithms dynamically calculating the shortest path. Your explanation details how this specific mechanism prevents single points of failure. And your link connects all of this back to the exact network scenario provided in the prompt. Whenever you see an answer that reads like a focused, logical progression, rather than just a random grocery list of facts, you are looking at the PEAL framework in action. It's a total game changer. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the strategy.
This entire process we just talked about relies heavily on evidence-based reasoning. In plain English, this means every single answer you provide must be anchored in a highly systematic analysis of the problem at hand. When you confidently state that a packet might arrive out of order, you can't just drop that fact and move on. You must provide the evidence-based reasoning. Routers independently analyze network traffic and hop counts, meaning sequential packets may travel via drastically different nodes with completely different latency. You are acting as a network detective here. You don't just report that a crime happened, you prove exactly how it happened, step by step, using the established principles of the syllabus.
Moving on to Section 2, the procedural framework, which is all about earning those crucial method marks. Let's look at the step-by-step strategy for tackling complex calculations.
This is where the real transformation happens for students. Remember Alex and Sam's answers that were just covered in red ink? Well, when we apply this procedural framework, those red marks magically transform into green check marks. When you're calculating packet transmission delays or routing metrics, the examiner is not just looking for some magic number at the bottom of the page. You must be able to extract critical data from binary representations, execute highly accurate calculations, and practically apply your programming and problem-solving skills to design and test algorithms. Imagine you're handed a complex network diagram loaded with binary subnet masks and varying bandwidths. Your first instinct might be to freeze up or panic. But a trained, prepared student practically applies their skills by instantly interpreting that data. They identify the payload size, they calculate the header overhead, and they determine the exact transmission time without missing a beat. Actually, stop scrolling for a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's dive into the actual steps you need to take.
To guarantee you capture absolutely every possible mark, you need to strictly follow this standardized sequence for systematic processing every single time you encounter a packet switching problem. It's 5 simple steps. Step 1. Identify key elements. What exactly is the packet size? What is the bandwidth? Get the facts straight. Step 2. Apply relevant principles. Ask yourself, are we calculating shortest path routing metrics right now? Step 3. Execute with clear working. Step 4. Verify your results. Do a reality check. Does a transmission time of 0.001 seconds actually make physical sense in this specific context? And finally, Step 5. Present it in the required format. If our student Alex had just followed Step 3 and executed with clear working, actively showing the math for calculating the number of packets required for a 5 megabyte file, they would have secured method marks even if their final division was slightly off. This sequence isn't just a suggestion, it is your ultimate safety net during the exam.
All right, on to Section 3, Critical Analysis. This is all about thinking like an examiner. For the higher order assessment objectives, examiners demand way more than just facts. They want to see deep evaluative thinking.
Top-scoring candidates prove their mastery by considering multiple solutions, carefully analyzing the trade-offs, acknowledging technical limitations, and justifying their final recommendations with rock-solid evidence. Let's do a quick mental exercise together right now. Imagine trying to extract a core trend from a really complex data table that shows packet collision rates across 3 different network topologies. The novice student just reads the numbers straight from the table and writes them down. The expert, however, actively analyzes the trade-offs. They'll write something like, while topology A has a lower collision rate, its hop count adds unacceptable latency for real-time video streaming, which is a critical limitation of the system. Do you see the difference there? That is justifying a decision using clear evidence, which is precisely what this matrix of evaluative action requires to get top marks.
When you are asked for a comparative analysis, let's say comparing packet switching and circuit switching, please do not just list isolated facts. You must explicitly identify both similarities and differences, ensuring you use comparative connectives to draw strong conclusions about their relative importance. Listen to this flawed sample paragraph. Circuit switching establishes a dedicated path. Packet switching breaks data into packets. The massive flaw here is that it lacks comparative connectives entirely. It's literally just 2 independent statements sitting next to each other. Now, let's rewrite that like a true expert. Whereas circuit switching locks up bandwidth by establishing a dedicated path for the duration of the session, packet switching dynamically routes individual packets, therefore optimizing overall network bandwidth despite potential variable latency. Boom. Connectives used, deep understanding shown, marks completely secured. Bringing us to our final section, Section 4, Top 3 Examiner Warnings. Let's look directly at the principal examiner reports to reveal exactly how students needlessly throw away marks on this paper. Consider this your final system to protect your grade. Make absolutely sure you avoid these classic traps that catch out thousands of students every year. Number 1, do not use an algorithm in the wrong context. Applying a local area network collision protocol to a wide area network routing question is a fatal error. Just don't do it. Number 2, never forget your boundary conditions during rigorous testing. Think about it. What happens if a packet arrives with a time to live, or TTL, of exactly 0? If you don't account for that specific edge case, your entire algorithmic logic fails. And number 3, always tailor your answer to the specific scenario provided. If the question is clearly about an e-commerce checkout system, giving a generic answer about sending an email is going to ignore the context and lose you valuable marks.
So, it begs the question, why do so many students struggle to secure marks on these multi-step packet switching calculations, even when they actually know the theory really well? It almost always comes down to cognitive overload. Under intense exam pressure, your brain tries to hold the packet size, the header size, the bandwidth, and the complex transmission formulas all in your working memory at exactly the same time. It's simply too much information. Just like a master swordsman who loses their footing because they are trying to think about too many moves ahead, students stumble. They rush to write down a final answer just to relieve the mental pressure, bypassing the absolutely crucial step of laying out their logic visually on the paper.
The answer to fixing that struggle is incredibly simple, as this quote direct from the examiner report highlights. Students hide their algorithmic decomposition. But you must remember this golden rule: always show your working out, because methodical evidence is your ultimate safety net. If you make a simple, silly arithmetic error when converting megabits to bytes, but you have clearly written out the formula and substituted the correct initial values, the examiner will award you the method marks. Your working out is the literal trail of breadcrumbs that proves to the examiner you understand the core principles of network data transmission, even if your calculator thumb slipped at the last second. And guys, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by.
By mastering these core principles, applying the procedural framework, and thinking critically about every piece of network data, you protect your grade and elevate your understanding of computer science. You now have the full blueprint to stop making the same easily preventable errors that cost so many students top marks. The only question left is, when you open that exam paper and see a massive, multi-part packet switching question staring back at you, are you going to panic like Alex, or will you execute like a master? Drop a comment below with your target grade for computer science and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.